Hi, this is week 2 lecture. It's summary of the lecture, and when you finish this video, I recommend you to go to the lecture slides or watch the actual class video to get more information about the topics. So in brief, what we're gonna learn here, we're gonna learn system force analysis, and also we will learn to resolve a system of two forces or in 2D or two-dimensional system, and how to combine two-dimensional force system together to find out the resultant force of the whole or the complete system forces. Force systems, what do you mean by force system? For example, in this bracket or in this figure, you can see the bracket attached to the wall. So this is the bracket here. The bracket basically attached to the wall by 2 bolts or more than 2 bolts, but in this case we have, for example, 2 bolts, one here and the other one on the other side. And there's a cable trying to pull this bracket downward in order now to keep the system in a steady state condition or make it a balanced system. These two forces going upward must equal to the force going downward. We call the whole system force system because we identify the effect of each part of the system and what kind of force, the direction of the force on that system. Now, we will give you an example about very soon about the force system and how to analyze it. But what I need to mention here, 3 important properties of force. The force is a vector. The force is a vector. So therefore, when we say a vector, we expect that we have a magnitude. This is the first thing. We need to have magnitude. For example, 10 Newton, 10 kilonewton, 2000 Newton, etc. And we need to show the direction. So the force, for example, here, if we have force in this direction, this one, for example, 10 Newton, I know that the value is 10 and the direction is toward upward, or let's say along a certain axis. The other property of the force, if we have any external force acting on a system, there will be reaction from the system trying to keep the balance, as we have in this bracket figure. So when the cable trying to pull the bracket downward, these two forces trying to pull the bracket or keep the bracket attached to the wall. The last or the third property that you need to know about the force, the principle of transmissibility. A force may be applied at any point on its given line of action without altering the resultant effects. What do you mean by this? If we have, let's say here, we have force F1 and force F2, and each one of them acting on the edge of the object. For example, this one acting, F2 acting on this point, and F1 acting on this point. I can extend the force on the same line downward for this, and this is also the other one. F1, I can extend it backward like this, and then the intersection point between these two lines represents the point A, the point where the resultant force of these two forces, resultant, are acting on the body or on the object. So we can change or transfer this figure to the this figure, and by this we can complete the drawing. We can draw a parallel diagram so that we can solve the unknown forces of this force system. So let's take this example to clarify everything, these three principles. Now, for this here problem, we have a structure or building structure or bridge structure where we have two beams. Beam 1, represented by force Fa, has a force 8 kilonewton, and another beam attached to the structure of the building, Fb equal 6 kilonewton, both of them fixed to this bracket here. One of them at this point, the other one at this point. We are already given the angle 40 between force Fb and the angle theta already given. It's equal to 55 degrees. Now, first thing you need to do in this type of question, we call this problem two-dimensional problem, because we have only x and y axis here. For example, I can say this is the x-axis and this is the y-axis. So I call this 2D system. And this system, if I know the angle here 40, the angle here 55, then the total angle of the line between both sides from this point up to this point is 180. So if I know this one, the first one is 55, the other one 40, the angle in between here can be found by saying 180 minus 40 minus 55. So therefore, we can get the value of this angle, which is found to be 85. So now we have these angles already known, and we have the angle of between the force F and force B. Now what we need to do is we need to complete, or we need to draw a parallelogram from these two forces. The way you draw the parallelogram is you can draw a force parallel to force Fa, like this, from Fb, and a force parallel to Fb from the head of Fa, like this. Now, when we complete this, then this is what we call parallelogram, and the diagonal of, as we said before last week, the diagonal of this parallelogram represents the resultant force of the force system. So this is R. Now, to find the resultant force R, we need to complete the parallelogram angles, or find the other angles of parallelogram. Now, I know this is 85, the left one, which is equal to the right one here, also 85. The remaining angles, because the total angle of parallelogram is 360, so therefore, we can say 360 minus 85 times 2, and then divided by 2. This will give us the angle on both sides here. So you will find that this will be equal to 95 degrees, right? So we know that we know these angles. This one is 95, and this one is also 95. Now, after I found the angles of the parallelogram, I can apply cosine rule to this triangle here, because we have two triangles. I can apply cosine rule to this triangle. And what we need to mention here is say r squared based on the rule, r squared is equal to the first one, which is f a squared plus f b squared minus 2 fa times fb times the angle between them, which is cosine 95. So if you solve this, you will find out the R value, which is 10.4 kilonewton. So this is the R value, the result of this equation. Now we can do the same thing with if we don't know one of the members, one of the beams forces. For example, in this problem here, I know the resultant force R already given. So here R is given, which is 10.41, but I don't know the force FB in this beam. So in order to find this, the same thing I can do, I can draw a force parallel to this force FB from the other side here, and I complete the triangle here. If I know the angles, for example, here alpha and beta, the angle alpha and angle beta is, or both of them are given. Alpha is 35, beta is 50. Then if I apply sine rule to this triangle here, I can find the unknown FB. This is FB here, the unknown force FB. If I apply sine rule, so what does sine rule states here? If I can say, if I have these two angles, I can say FA divided by the angle opposite to FA sine beta is equal to the force FB, which is unknown force, divided by the sine of the opposite angle, which is sine alpha. And then I solve the problem here. I can find the value of FB, which is 6 kilonewton. There are so many real-life applications using the force system analysis. For example, here in this figure represent an example of surgical replacement of knee joint. And in order to replace a knee joint, you need to design a proper artificial joint that can resist different type of forces. So what they do, like here in what they do in this, for example, in this figure, you have resultant force, or the force acting on the knee, 360 Newton. You want to find the effect of this force on different components. So we have, let's say here, component Y prime here, and the other one on X direction. these two are two components, I can analyze the force, I can resolve the force into two components, and then use the parallelogram method to find out the these forces Fy and Fx. Same method, same way we did before. You can either apply sine rule if you have the right information or right values to find them, to find the unknown force, or you can use the cosine rule if you know the angle between two forces. In this case, we don't have the angle between two forces, but we already have the other angle, so we can apply easily sine rule and find the unknown forces Fx and Fy. Other example here also, I will not go in details here, but I need you to go through the actual slides of this lecture and also the recorded class of this lecture, week 2 class, and try to understand and try to work on these examples and find out the unknown forces by ourselves. The last thing I need to mention here in non-perpendicular forces system, if you have, let's say, more than two forces, for example, in this object, we have force F and F1 acting on one side of the object, and we have F2 and F minus F on other side of the right side of the object. We can analyze each two forces individually to find the resultant of these two forces. So, for example, the left side, I can find R1, the resultant of these two forces, and also I can find R2 for the right side forces. And then I combine R1 and R2 in another parallelogram. And this is the new one I got. This parallelogram represents the summation of the other two forces. So the summation of resultant of other two forces. So if I complete the parallelogram, I can find the total resultants of all the forces acting on the object. So R will be the resultant or total resultant of all forces acting on this object. I will follow this video with another video. Another video will talk about the two forces normal on each other, how to find the resultant force of these two forces.